Welcome to ICCII Compiler 2 2016.12 update training on Signal EM and ECO. Today we'll be talking through the latest Signal EM enhancement and new ECO differentiation features in ICCII Compiler 2. The first feature is Signal EM enhancement ICCII Compiler 2 ALF support. Previously, in ICCII Compiler 2, Signal EM analysis only support ITF EM format. However, most foundries are still offering ALF, so user might need to translate ALF to ITF EM format in order to run ICCII Compiler 2 Signal EM analysis. To avoid the additional translation task, we have added ALF support for ICCII Compiler 2 Signal EM analysis from 2016.03-SP1. The updated command read Signal EM constraints have two options. The first one, -encrypted, indicates that the EM format file is encrypted. It is exclusive with the option -format. The other option is -format. It specifies the EM file format. The supported formats are ITF and ALF. If this option is not specified, the data will be read as ITF format by default. This option is exclusive with the other option -encrypted. Next, we'll be talking through the new ECO differentiation features introduced in the latest ICCII Compiler 2 release. First project is max fanout support in split fanout. This project provides several enhancements for the command split fanout. Split fanout is an existing command in ECO flow to implement load-based buffering. In this project, we made several enhancements, including it now support user-defined max fanout value and enabling manual max fanout violation fixing. Second, it is now blockage aware and VL aware. Third, we enhance this command to minimize physical impact when adding the buffer. Fourth, auto punch when route topology is inconsistent with logical connection topology. These are the UI changes for the split fanout command. The new options are -max fanout. It enables manual maximum fanout violation fixing based on the input number from user. The number must be equal or greater than 2. If -onRoute option is used, the buffer will be added based on the route topology. Otherwise, the buffer will be added based on the logical connectivity. The second new option is -respect blockages. This option is to ensure that no buffer is added inside a placement blockage, soft or hard macro, with or without keyboard margin. If this location of the new buffer cannot meet split fanout requirement, error message will be issued. This option is used only with -onRoute option. The third option is -net. It specifies the net for split fanout to add the buffer. Next option is -driver. It specifies the driver of the buffer. Each of the pin ports specified must drive a net, which will be used for split fan-out. Also, each net must contain one or the only driver. The next option is dash loads. It specifies the load to be driven by the buffer. It cannot be used with dash max fan-out, and also it cannot be used with dash net or dash driver if dash unroute option is used. The last new option is dash hierarchy. It specifies the hierarchy of the newly added buffer, and it can only be used with dash loads and when dash unroute is not used. In this slide, it tells us the usage flow for split fan-out. Starting from post-route design database, user then can do split fan-out as needed. After split fan-out was implemented, we then continue with place ECU cells, dash legalize only to finish placement and legalization, and then use route ECO to finish route, and then user can check the result. These following two slides show several examples on the usage model. The first one example, user-defined dash max fan-out and the logical net ABC, as well as unroute option, and thus the buffer BUF1 was added in this location to meet the requirement of dash unroute option. The bottom one, since unroute option it was removed, the buffer BUF1 was added here instead. For the example on the right hand side, BUF2 was added here because user specified load changed to be U2 and U3 and U4. Next example is with dash respect blockage option added. For this case, we have a blockage with kickoff around the route. To meet the requirement, the buffer BUF1 is added outside the blockage here. Then for the bottom one, user changed the load to be U2 and U3. The two issue an error since there's no valid option for BUF1 to be added. The next enhancement is ABOR with physical fit-through support. The existing add buffer on route command was not able to add buffer on route segment which are physical only or inconsistently cross voltage area in the previous IC compiler 2 release. For example, this green buffer in this figure. With this enhancement, ABOR command will support buffer added on route over any voltage area, including physical only fit-through voltage area or inconsistently crossed voltage areas. Here are the UI changes for ABOR command. A new option called dash allow physical fit-through buffer it is to specify voltage areas that buffer could be added inside, even their physical only feed-through. This option must be used with dash respect voltage area and dash voltage area specific ref cell options. We can only specify the primary VA. A new command called set ECO power intention to set valid supply net for the buffer cells. If the power domain inherited from a buffer's hierarchy doesn't align to the voltage area for the buffer location, it will assign the buffer as an instance element of the correct power domain aligned with the voltage area. The field cells in this command will be put into a collection called ECO update supply field cells, and user can remove these cells with remove buffer. This slide shows the suggested usage flow. Starting from a post-route design database, user can do a check and redesign first, and then use add buffer on route with the intended options. After add buffer on route, use the new command set ECO power intention dash cell to update the supply nets of the newly added buffers, and then use check and redesign again to check the result. Here are the limitations on the current add buffer on route command. It doesn't support cross physical hierarchy, and it doesn't support the gas station together with power domain on instance. The next new feature is user manageable programmable spare cell mapping. This project provides trail map feature for programmable spare cells. With this feature, Place Free Silicon can move ECO cells to targeted spare cell locations without swapping them. User then can do analysis on the result and then perform manual spare cell mapping if they are intended. The mapping information also can be written out for map free silicon command to do the mapping. This feature has several benefits. It allows user to analyze before actually committing the spare cell mapping result. And then it also can provide flexibility for user to manage spare cell mapping for desired QOR result. There are three new options for Place Free Silicon command. The first one is -no spare cell swapping. It is to enable the trail map feature. User can preview the mapping results and then do analysis and manual remap of the ECO cells if they need it. A new cell attribute called fs_mapped_cell_name is used to record the mapping relationship. The next option is -map spare cell only. It performs spare cell mapping based on the existing ECO cell location. This option can be used after you apply -no spare cell swapping and finalize the location of the ECO cells. It is mutually exclusive with -write map file. The last option is -write map file. It is to write out the ECO cell and spare cell mapping information to be later used by map free silicon command. If user manually moves the ECO cell after -no spare cell swapping, the command removes the relationship of the mapping pair. A new cell attribute called FS don't use. Spare cells marked as FS don't use will not be mapped. Thus, user can select spare cells in a congested area and prevent the spare cells to be used. This is the usage flow of this feature. First, user apply netlist changes and check ECO cells and available spare cells. And then, to do user manageable spare cell mapping, we could use -no spare cell swapping option with place free silicon command and move ECO cells to the location of the candidate spare cells without actual swapping. At this point, user can do analysis on the QR and make manual change to the mapping results. For example, user can check ECO cell connectivity to see if the trial mapped location is reasonable. And also, user can run timing and congestion analysis to determine if the location of the ECO cells are acceptable. If there is a need to adjust the mapping, create a ECO cell collection sorted by the desired criteria. And for routability, mark spare cells in congested area as FS don't use. This flow can be iterated several iterations if needed. User can also manually adjust mapping of certain ECO cells by running place free silicon -no spare cell -map spare cells only with -cells. It evaluates the new trial map results. Then evaluate the new trial map results. It may need to iterate between trial map and analysis more than once if needed. After user finalized the mapping results, then can use place free silicon -map spare cells only to commit the mapping. After user finalized with the mapping results, they then can use place free silicon -map spare cell only option to commit the mapping. Also, manual spare cell mapping can be done with map file. First of all, use place free silicon -write map file to write the mapping file, and then use map free silicon -map file with the correct map file to do the mapping. Thank you.